Here's an easy SAT math question. However, it's a very important question because this type of question comes up on the SAT a lot. Let's begin. The question says, in the linear function f of 0 equals 25 and f of 1 equals 15, what equation defines f? When they say linear function on the SAT, we're talking about f of x equals mx plus b, where m is the slope and b is the y-intercept. Next, when they gave us that f of 0 equals 25, you have to remember this. When you're given f parenthesis of something in the parentheses, that value represents the x value or x coordinate, and then on the right side is the output or the y coordinate of the point. So when they say f of 0 is 25, 0 is the x coordinate and the y is 25. Simply 0 comma 25 is what they're talking about. Why don't they just say 0 comma 25? Well, they want to make the question more difficult than it has to be so that it would be an SAT math question. On the right side, same thing. F of 1, that's how you read it, f parentheses 1, is where 1 is the x and the 15 is the y. So we have a point, 1 comma 15. Then to find the function or the equation, we want to first find the slope, where slope is represented by the letter m, and slope is where you do the y minus y on the top or in the numerator, all over x minus x. Where if you simplify this, you get negative 10. So we have f of x equals negative 10x plus b. One thing I want to mention is that normally we have a y on the left side. However, the question says specifically they want the function f, not the equation f. Hence, we need to use the f of x instead of the y, which is not a whole lot of difference. Continuing on, to find the b, or the y-intercept, we need to go ahead and plug in one of the points that were given by the problem, either the 0, 25 or 1, comma 15. If you notice that 0, comma 25 is the y-intercept, and that 25 is the b value, then you're ahead of the other students. However, if you don't see that, let's go ahead and plug in 115, see what happens. What we're going to do is put 15 for the y value or the f of x value. We'll put in 1 for the x value, 1 for the x, 15 for the y or f of x, plus b. And if you work this out, you see that b is going to be 25, as we had mentioned before, 0 comma 25, where 25 is going to be the y-intercept or the b value. Then our final answer or the function is going to be negative 10x that we started with, plus the v value, which we found to be 25. And that's going to be our final answer for this SAT math question. Now let's go on and do another one that's going to be a little bit more challenging, a medium difficulty level for the SAT math. For this medium difficulty level question, we're going to be using a rule that you'll all need for the SAT math. Let's begin. The problem says, in the given equation, b is a constant. On the SAT, if the question mentions that something is a constant, you could pretty much ignore that. And then the question goes on to say, for which of the following values of b will the equation have no, that's the key, no real solutions? Notice that we have a quadratic equation and the answer choice is, of course. When a problem gives you a quadratic equation such as this, quadratic equation, of course, is when you have x squared in the equation as the biggest degree. You want to use this rule, where given ax squared plus bx plus c, a quadratic equation, and This is called the discriminant, by the way. B squared minus 4ac equals 0. That's where you get one real root. However, if b squared minus 4ac is greater than 0 or more than 0 or positive, you get two real roots. But if the b squared minus 4ac is less than 0 or a negative value, you get no real root. And that's what we're doing. And remember, we're doing the no real root. So we're going to be focusing on the third one here, where b squared minus 4ac is less than 0. So let's go ahead and set that up. First, I'm going to write down b squared minus 4ac is less than 0, as we had right here. By the way, you do need to memorize this. B is going to be the coefficient of x. In this case, b, of course, is what we're looking for. A is the coefficient of x squared, 5. And then c is the number by itself without an x next to it, which is 20. If you do 4 times 5 times 20, you get 400. Bring the negative 400 to the right side. Instead of adding 400, I like to take that negative 400 and just bring it to the right side, where the sign changes from negative to positive. Now let's take a look. If I take a 22, put it in here, is that going to be less than 400? Use your calculator and check that. 22 squared is more than 400, so A does not work. What about B? If I take that 15, plug it in here, is 15 squared less than 400? Yes, because 15 squared is 225. It is less than 400, so B is the answer. If you want to check answer choice C as well, we can. Take the negative 20, plug it in here. Is negative 20 squared less than 400? Well, negative 20 squared is going to be positive 400, and it is not less than 400. It's actually equal 400, so that's not true either, meaning C is no good. Likewise, if I put in that negative 25, plug it in here, negative 25 squared is 625, and it's most definitely not less than 400, so that's no good either. The important point of this question is that when given a quadratic equation, and the question talks about either no real solution, one real solution, or two real solutions, you want to use this rule, the discriminant rule, where b squared minus 4ac will tell you, depending on if it's equals 0, greater than 0, or less than 0, will be 1, 2, or no real solution. Again, I've seen this question many times on the SAT, and I have a feeling that this will show up again on your next SAT. So that's it for the medium level question. Let's go ahead and do a real tough one, a hard or difficulty level high SAT math question. Here's a question that's considered tough on the SAT math. In the equation below, k is a positive constant. Which of the following is one of the solutions to the given equation? And here's our equation. So the first thing we want to do is take this k squared over square root of y squared minus k squared to the left side of the equal sign, so we could combine these two fractions. So this is what we started with. Once we bring this to the left side, it turns into negative. The whole thing equals 45. Since we have the common denominator as same common denominator here, we could combine the two fractions. Let's do it. And we could combine the y squared minus k squared all over square root of y squared minus k squared. However, if you see, if you have difficulty time combining the two, here's what we could do. We could let u equal y squared minus k squared, meaning we could rewrite this equation as u over square root of u equals 45. When taking the SAT, you want to notice these things. You want to notice that y squared minus k squared is on the top of the fraction, and also y squared minus k squared is inside the square root sign, but underneath the fraction. There's got to be a way to do something with these two so we could combine them or simplify them. And one of the ways is use substitution like this. So if you have u over square root of u, that's the same thing as u over u to the half power. When you have u and u to the first power like this, we subtract the exponents. We learned this in pre-algebra, where we get u equals, or u 1 minus half is 1 half, u to the half power equals 45. So we simplify that u over square root of u into u to the half power, which is same as square root of u. Let's go ahead and take that y squared minus k squared back into the u. So we'll take that, substitute it back in for u, where we get square root of y squared minus k squared equals 45. Since we're trying to solve for y, we got to get rid of that square root sign by taking the square of the left side and the square of the 45. Where the square sign and the square root sign will cancel out, leaving us with y squared minus k squared equals 45 squared. Then we want to bring the negative k squared to the right side so that the y squared will be by itself. So we want to bring this to the right side, where we get y squared minus, or y squared equals 45 squared plus k squared. Then our final step to get rid of that square root sign is to take the square root of the left side and square root of the right side, where our final answer will be y equals plus minus. Since we took the square root of the left and the right side, we need to add a plus minus sign. Square root of what we have here, 45 squared plus k squared. The reason the question says they want one of the solutions is because we got two solutions for this equation. We have the plus root 45 squared plus k squared, and also the minus or negative square root of 45 squared plus k squared. Let's take a look at the answer choices. Do we see either the plus or the minus square root of 45 squared plus k squared? Yes, we do. Right here, answer choice C, we see k squared plus 45 squared, which is the same as 45 squared plus k squared. By all means, this is not an easy SAT math question. It's definitely a hard question. However, by taking the k squared over square root of y squared minus k squared to the left side, and see that you could combine the two fractions with the common denominator. And then if you're able to simplify this portion directly, that's awesome. If not, you could always do the substitution method that I had used here and then solve the rest of the equation. This will be a very difficult question to do on decimals. I'm not even sure how you would do this on decimals. This would have to be done by hand. So there you have it, folks. Once again, we've done an easy, we've done a medium, and hard SAT math question. Come back again or check out my other videos for more explanations on SAT math problems.